Okay, before the break, we were taking a look at Amazon AWS DynamoDB, which is AWS's go-to key value pair, key value store, where we store all our data in key value pairs. There's the regular AWS console on the web page. We can interface with it. It's a dynamic web page. It changes. Buttons will move around on those, things like that. And personally, I went with Google Cloud just because I like their style sheet better. Something about the colors Amazon chose that I just I like Google's style sheet better. That was the sole purpose for my choice between the two. But anything we have on AWS and Google Cloud follow the same standards. They have a very similar thing that we can use there. So the web interface is here if you want to use that. But because of who's on the roster in this class, we've been looking at it. How to do it in a console, a terminal, shell, or through text. Everybody in here is either, I think everybody in here is either data analytics major or a software development major. So the sort of people that should be working on with AWS through a text file, not through that. Speaking of text files, you might want some reference stuff because after we close this, obviously it's going to be closed. So as things are working, make sure you copy the stuff from the terminal and you can just put it in a new file up here. I don't know, reference stuff. And if you that probably should have been .txt. If you right click on it, there's a download button so that you can keep any reference material around. That can be useful. We're just seeing some basic examples here, just getting started. Using Cloud9 instead of just the terminal, so we have the text file and this. And well, the last example we did before the break, we put our data in right from here, and you can see that's kind of a mess. So normally we would do it up here, put it in a text file, but one item at a time still takes a while. Probably want to be able to do this lots of items at a time. So I'm making a new text file or a new JSON file. So a little plus sign, hit new file. And I always like to save it first. That way the predictive text is accurate for what should go in a JSON file. If we don't give it the .json extension, it won't automatically type the closing curly brace every time we type an opening curly brace and get the color change and things like that. I don't know, maybe lots of items .json. And again, it was mentioned beforehand. Remember, JSON is just a layer of abstraction that allows us to work with the database. It's not a JSON database. If we want to store stuff in JSON, all we have is really like a text file. We have to read that entire text file every time. We can't jump around with it. There's a few changes. So it's going to look a lot like this one. Here we have what one element looks like, but we need to extend that a little bit. So again, we'll set some open ending curly braces for our overall JSON object that we're passing to the database. And the first thing we have to put is the table that we want to work with. So our table name was people. And the value for that is going to be this a large array. So then some square brackets for all of the stuff that goes in it. All of the items we're going to put in the table. And each one of them is going to be another JSON object. So we need opening and closing curly braces for every single element in there. So then a comma between them. We'll get to that comma in a second. I'm gonna spread that out a little. So in each element, we have a very special key we have to put here. So put request, and then again, some curly braces because the put request is going to be a JSON thing. And one more special one, item with a capital I, gets another JSON one, and then that item is like this. So it's kind of like we have item here out front of that single one. We did a single item. So then here's where our key pair, our key value pairs that actually go in there are. So person ID, we had a partition key, so a single element primary key instead of a composite key. And unlike normal JSON, data type matters, so we have to say what it is. So this one's a number. So in, and I can't remember what number we're up to. Looks like I have a 4 in there. So maybe a 5 or 6 or something. I don't think I've inserted a 5 yet. I'll throw in a first name, which is name's a string, and maybe Mary. Who's from the town. Town names are strings, so Marysville. There's a couple local towns. And for a car, maybe Mary drives a 2021 Mustang. So that's what we have to do if we want a bunch of them. So we have to say what table it is, and the table gets a big, huge array. And then inside of that array, all of them are JSON objects, at least as far as what we're passing in. So some curly braces, and then we make a put request, and obviously that extends further. There's other things we can do afterwards, but not on day one introduction to it. Just a quick pass looking at some of what we have. Then we get to our actual item. So these are specific things, case sensitive. DynamoDB will be looking for those when we try to write a bunch of items. Make sure you have those keys in there. Then whatever keys you required to be put in there, and set your data up like that. And then I'm going to copy this to do the rest. So comma, and then add another one. Maybe our next item. Okay, so that was 5. We're up to number 6. First name of I don't know, Becky Borden, from the town of Borden, and high school reunion hotel. Following that thing of unstructured data, the stuff we would get off Facebook and stuff. We know what hotel her high school reunion was at. Might seem trivial for our normal classroom examples, but knowing something like that is that's like the gold medal for marketing. If the marketing, right, those targeted advertisements, if they know exactly what hotel you're going to be at in a couple weeks, they're going to start showing you ads from everything they can get money from within a mile or two of that hotel. So scattered random data that we can find. It's not filled out forms, so it doesn't fit nicely in the table, but we can find that information and we can do stuff with it. Right? If we know where Becky's high school reunion is going to be held, we can show her ads for all the restaurants near that hotel, or clubs near that hotel, or other things near that hotel, because she's going to definitely be in that area. I'm just going to make something up for the result there. And note it, so you can see that structure. I'll paste another one in. This will probably be good. So number 7. We know their last name. I'll do it Jones this time. Another common name. Probably don't know what town they live in. They're at that same high school reunion apparently. And what's another good data point? Hair color. Hair color. String and I don't know, red. It's a good hair color. And So notice where the colons and the commas and all of that go. No comma at the end. That will throw an error. You might remember before the break, whenever some error messages were mentioned, that was the first thing I checked. That'll give us a couple more data points to put in there. So 3 more things. And when we write this, again, we're accessing AWS. Seems odd in this terminal, but we're doing it secure shell. So we can do that from any computer in the world. Typing AWS first makes a lot more sense there. Any other computer in the world than the one we're actually typing it on. We want to do stuff with the DynamoDB resource. So everything in AWS starts that way. AWS S3, AWS EC2, AWS RDS for the relational database. So AWS and then the resource. We're looking at DynamoDB. And then the command that we want to do. The next one, we want to write a whole bunch of things at once. So that's a batch file. And our command is going to be batch. Whoops, that's a dash. Batch, I keep doing underscores. Batch write item. And then we do request dash items. Notice those first couple things, AWS, then the resource, and then the command do not have any dashes, and everything afterwards, all the parameters all start with 2 dashes. It is consistent like that, and then a space, and then the value to fill those, which we just wrote a big file of JSON stuff. Remember to save it. It's a really easy thing to forget. Saving's trivial, and after we do all the hard thinking about what data needs to go in there, easiest part to forget. So file, then colon / because it's a protocol, and I did not put it anywhere else, so we're in the environment folder. There on this, it's actually running on an EC2 server. So lots of items.json. And then with our database stuff, we can have distributed database. So we do have to say what region it is or what regions we want to write it to, because normally we wouldn't have our entire database in Northern Virginia like our class example is. Some of it's in Virginia, some of it's in Beijing, some of it's in Germany, and our database is scattered all over the world. So we have to say explicitly where we want to write it to. And we're in US East 1. And notice this one does expecting a comma on line 7. I did put a comma on line 7. That error message is not helpful at all. Unless the lines here aren't really the same as the lines that it's interpreting. Or look somewhere else and see if there's a missing comma. Oh, let me double check my example from getting ready. I need a comma there. Okay. So open, comma. It's the last one, so no comma. No comma, then a comma there. Uh-oh. Does anybody see a typo? lot of times more than one set of eyes can be helpful. So key type data. Key type data.
Can you zoom out a bit so I can see more of it?
Um,
Or you want to go line by line?
how good's your eyesight, or how big's your screen? Can you see that?
I can zoom in on Zoom, like on my screen, so I can get it closer.
So there's a lot of it's there.
Yeah, I can see it.
Invalid JSON, expecting a comma delimiter as line 7. Line 7's right here. There's a comma before it. A comma after it. A colon's inside there.
It's probably on a different line.
Yeah, I don't think line 7 is actually line 7.
I'm getting a different error than you, so.
What's yours say?
You know, wait, no, never mind. Mine just says unprocessed items. Or I guess it's not even an error. It just says unprocessed items.
You share your screen?
Yeah.
I think that actually worked. If you share your screen, whenever it pulls up, I don't see anything though. Oh, there it goes. That took a while.
Sorry. I was getting it.
So that one is deceptive. Yours actually worked. If you go over to the DynamoDB and run that again. So all of them are in there, right?
Mm-hmm. Or are they
Yeah.
out of order?
Did it miss any of them?
No, I don't think so.
Okay, yes. So that is the confirmation, which is really, really strange because, well, if they all work, if you had something that went wrong, then you would see it in that list. So if I share, when I go back to share my screen, like the whole list pops up, the entire file is unprocessed items. But you didn't have any that were left off. Not the way I would have wrote the confirmation if I put that code together, but it definitely throws people off.
I didn't do exactly what you did though, so I wonder if I don't know if that has anything to do with it or not. Mine a bit differently. But it's not, I don't think anything so different, you know?
Yeah, I'm pretty sure mine's can I go back to share my screen?
Yeah.
Yours definitely worked. So all of the concepts are right there. It's just missing a comma somewhere.
Would it matter about the order of your input so you have it as 5? That doesn't matter, right? It doesn't need to be in order. I mean, you have 1, 2, so I guess it doesn't need to be in order. That's not something that matters.
No, it doesn't have to be in order. I was just doing that to keep track of it. Yeah, so notice it received all of this stuff. Maybe I'll see the error message.
Are you missing a curly brace somewhere? Brackets somewhere? I don't know. It looks like you have, hold on, look at
It should highlight them. So that one closes that one. Oh, yeah, I am.
it's always those.
Closes what? Where's that?
I don't know
Okay.
though. I only have 2 in between my.
Wait, go back to under people. The curly bracket, it was like highlighted red. Oh no, never mind. Never mind. It's fixed.
That's how to keep track of them, isn't it?
That one closes that. That one closes there. Is this just an extra one?
Yeah, I think that one's an extra one. Did you just add that though? Oh, I see it. You have a sorry, I got excited. You have a parenthesis instead of a bracket or a curly brace.
Yes, that is one of the biggest reasons that software developers work as teams. Even on small projects that one person could do on their own, 4 eyes is way, way better than 2 or 6. It's hard to see those things. And I copied and pasted that, so that means that same parenthesis is everywhere, isn't it? All right, let's try this again. Oops. Clear, and then AWS DynamoDB. I always get the order of this one backwards. Batch write item. I don't know why, but for some reason my mind would have put that one backwards, and I constantly write it as batch item, right? So I always have to pause. Yeah, it's always much easier to remember the names that we created and not the ones other people did. Well, kind of like that confirmation message that you saw, Janet. It makes you think there's an error message when you see a list of unprocessed items. And then that is in this file, / lots of items.json. Oh. And do it on the US East 1 server farm. Oh. DB batch write item. Oh, I forgot a parameter. -- request items. In the file. There we go. So no items were left in the unprocessed items thing. That's not exactly the way I would have wrote that confirmation message, but then we come over here, we see all of our data showing up over here. But since we've been doing all our work in the console, it'd probably be nice to see the stuff in the console, right? AWS DynamoDB and well, over here in the console, we have these 2 options on how we grab stuff, scan and query. Query is a little more complicated. We have to use what's called global secondary indexing and identify certain fields as searchable and some extra stuff. Scan returns everything. So I'm just going to do that because we're starting off. Over half the class is software developers. You're probably just going to grab your entire data set and throw it in your program and use an if-else structure to figure out what part you want. So this would be the starting point. So scan, and then the table name. Table-name people. And here we do not have to put in the region because we're allowed to have distributed databases. So the people table could be spread to 10 different regions around the world. So AWS DynamoDB, we want to scan this particular table, and that will bring back all our data. So when you have a program like that would be, that's a command you could pass to the server from your program. Or you could grab that and echo it into a file, normal bash stuff, right? So I run that command, the normal bash thing, will put that in data.txt. And then we have it all in a file, or put it on a URL, and that's sort of the bare minimum to call it an API. Technically, it would be an API. Most people wouldn't call it an API if there's no security measurements or anything. If we're just transmitting JSON freely across the internet, most people wouldn't actually call it an API, but it would fit all the definitions. So then we have all of our data to work with. That is just the bash command. One little arrow writes it to a file, and 2 arrows appends it to a file. So kind of like echo, put the results of that into this text file, if you haven't seen that before. So that gets us, we can store our data, make a big JSON file where we can go back and edit it. It's a lot easier to edit it there, and then batch write it all at once. We can grab all the stuff. And I mentioned that queries are a little complicated. So without getting into secondary indexing, how can we do a little bit better than our data? And we saw earlier we had put item to put things one at a time. We can also get items one at a time. So that does allow us to filter it down some, but we do have to know which item we're getting. So hopefully by now you can predict the first couple words, AWS DynamoDB. That's our service and resource. Then our command is we want to get item, and to get item, we have to pass in a key. And it goes in this format. So we do have to type the JSON format here. So I usually do it with a single curly brace single quote mark surrounding all of the JSON and double quote marks inside of the JSON. You can also use escape sequences, just a backslash quotation mark if you want to do that. This usually doesn't go very many layers deep. So mixing single and double is usually enough to grab JSON this way. So a single quote mark, and then we have to pass this in as a string, or put your key in a text file. That's a little bit neater and easier to edit and that sort of stuff. But the key, first off, we should try to always look for our partition key, or the primary key if there's 2 parts of it, the partition and the sort key. But person ID, and then, person ID was a number, and maybe we want number 4. I think there's a 4 in there. Where's the curly brace to do that? Do I need a region here? I don't think I need a region. Oh, that'll be it. Nope, I did mess something up. Oh. I made a silly mistake there. Does anybody notice what I forgot to tell the computer? We've been creating tables, right? And then throwing key value pairs in there. I told it to grab a key, but not where to grab the key from.
Table name.
Yeah, to just randomly say key. There's an awful lot of databases in the world that would have to be searched to find that key. And there's probably an awful lot of things with the ID number 4. So table name people, and then look for that key. Sorry, I just overlooked that. I was jumping ahead to thinking about the harder part. And then that gets us our stuff one item at a time. So then we could say, do that, and then write that to greet.py. So then we have this in here, which can very quickly be edited to something. Can I do this in multiple lines? data equals this. I think I have to get all those line breaks out of there. There we go. And then we could print hello plus data first name. Right. So that we're actually doing something with it afterwards. I think everybody has seen Python, right? We're not doing anything fancy in Python. Hopefully you recognize the print. If you haven't seen Python, hopefully you can tell what the print statement means. But we have our data, and then we can access it and actually do stuff in our program. Oh. So I need to double up the keys. Now we go to run. Eventually I might get it right. There we go. I put a bit too much in there. So I guess we need a third key to finally get down to the actual point. Hopefully y'all can see the general idea there. Once we get our data back from the database, then we can start using it in the program to actually do stuff. And we didn't need our entire database. Right, we brought that in over here. We have a bunch of data in there, but we only needed one little piece of it. So that's the power of the database, being able to filter it down to only the part we need is brought from storage over to RAM. We don't have to bring our entire data set into RAM when we only need like one little piece of it. So we have that same functionality. I think that was everything I had on my list there. Oh, yes, close that one. And I'm going to go ahead and close this, but you might want to make sure you scroll up and copy all of those commands that work. So if we come to terminal and keep hitting up, we can go back and see all the different commands that we ran that made everything work. Just for some sort of reference. Stuff.txt. And then when you right click on it, there's a download button right there. That way you keep your reference material around. That had all of the points I wanted to talk about there. If I scroll way up here to where this terminal started, so I didn't really close it. So we saw how we can list out all of our different tables. We have more than one table and interact with them together. Set up a name and give it key value pairs. Read the stuff in from a file. We did see one example where we just typed the JSON directly. That was kind of a mess. That was mostly there as an example to show you why it's important. Why it works better to type it in a file, even if you're doing it one item at a time. Have a lot easier to work with there. Or if we have lots of data, just watch those keywords it's expecting. So table name is an array, so square brackets. Then everything else is curly braces. And we do a put request for each item. Hopefully put request sounds familiar to some of y'all. It may seem a strange word right now, but two of our very important words from at least CRUD, a couple different ways we can interact with servers. If you're not familiar with what I just said, CRUD, create, read, update, and delete. The four things we want a server to do. create files, read files, update those files, and delete those files. Put is one of the things we can do with that. It's like a post, only extra layers of protection. This isn't a server admin class. And then a request is where clients make requests of servers, and then servers send responses to fill those requests. Just like clients and servers in a restaurant situation. So those words are important in the item we're going to put in. And then we can scan the database to get all of it, or we can use get item and pass in the key we want to get. Usually when I look for the partition key, because to use any other keys, it's kind of hard to guarantee on, and it might mess up if it hits too many blank spots. If it hits too many missing keys. So you want to use the one that is guaranteed to be there. If you knew every single one of your data, everything in your data set had a first name, then you could probably get away with searching for first name. But even then, it's kind of iffy. You should use one of the required keys. Probably shouldn't even mention that other one. So some starting functionality on that. It's not the whole thing. And make sure you take screenshots of that. Just remember for that assignment that there was no SQL assignment in module 7, but I forgot to write instructions for it and realized it over the weekend. So it's like, well, let's do it for the class examples. Take screenshots of this. And then on Thursday, I guess we'll look at the other most common type of NoSQL database, which is a graph-based NoSQL database. It still uses key value pairs. We always use key value pairs. It didn't seem like it in the regular MySQL stuff that we've been looking at the whole semester with the tables, because multiple things have the same key. The key is the field name, so we don't have to type the key every time. With our other types, with our NoSQL databases, we have to type the key for every single value. That's really the difference between them, is how often do we type the key? The same key apply to lots of things, or do we type the key every single time? But maybe take some pictures of that, and you can keep it open for a while. If you signed up for that course, you have till Thursday, you have till Sunday. It'll close Sunday at 11 p.m. I don't know why midnight wasn't an option, but it does close an hour earlier than Ivy Tech. I guess, yeah, I'm not really sure why I had to choose the 11 o'clock option. But when you're done, you want to clear up all the resources. So if you go into the things we did, so we did some stuff in like Cloud9. Actually, when you hit End Lab, it'll do this automatically. But when you're actually doing stuff, it won't be automatic. So you want to make sure you're not getting charged for like this IDE after you're done working in it. It's like, okay, the project's done. Don't need the IDE that was used to make the project, or the one in AWS automatically comes with the Git repository. So we don't need to pay for using the IDE and the Git repository now that the project's finished. So you want to make sure and hit the delete button and free up all the resources after you're done with it. It takes a minute to delete that one, so I'll go back over here. And in the learner in the sandbox here, when we go into the DynamoDB and select tables, we don't actually have permission to delete it. Well, we do, but deleting counts as a type of scaling. So I'll type in the word confirm and hit the button and get this error message because we're not allowed to scale the database. But we're not scaling it, we're deleting it. The computer just thought it was, thought we were trying to scale it. It's like, hey, you want to change the size of this? You're not allowed that. You're not allowed to change the size. Not allowed to auto scale it in the learning environment. Yes, if you end the sandbox, it will work. So basically from all of your stuff, oh, let me create a new table here then. So whenever it's finished creating, Jenna, was that who asked? Was it? Oh, yes. So whenever it's finished creating, you'll have a checkbox. You go to the main page where you see everything. So like on the DynamoDB dashboard. Oh, and a whole lot of the dashboards have a little video with them. So if you scroll down past the create button, you'll see a little video to help you get started. Under like tables, that's the main thing we're creating. You hit the checkbox over at the left, and then under if there's not a delete button directly, it'll be under actions that you can take on it. Most of them have their own delete button, and then you have to type some sort of message, usually either the word confirm or delete. It'll tell you what to type, and then it'll go ahead and delete it. Ignore that error message on DynamoDB. It thinks we tried to change the size dynamically, and we can't do that from the learning environment. I guess technically deleting it is dynamically changing the size. And even though coming over here and hitting the end lab button will shut down all of those resources, you want to form that habit because they will add up. So it's really easy to do stuff, especially if you do it on like the first or second of the month and then forget to shut it down and you don't get the bill till the next month, and then you left something running around the clock for a full month. Think about your utilities. If you left your heater on for a full month, that's going to run your bill way up. If you left your water running for a full month, right? If you leave for a month and your faucet's on, you're going to have a huge water bill next month. Same thing with cloud. We pay for usage, so you want to get in the habit of managing those usages. And get some screenshots of that stuff, and then that's what you will submit for that assignment. And there's another one to look at on Thursday, which like today will also be recorded. It'll be much shorter. It was going to be 20 minutes, but that was a bunch of information now. That is something you will definitely see. And also because we use that sandbox, you have access to that sandbox and a $40 budget for AWS until Sunday. And I was doing stuff for like 4.5 hours straight instead of that budget. So that'll go away. That $40 will go quite a ways if you just want to play around with AWS stuff between now and Sunday. And since everybody's a software developer or data analytics major in here, play around with that cloud IDE and see what developing code right there on their website's like for you. Anybody have any questions about that? And if you did take screenshots and want to submit them, even though it's spread out into 2 parts, it's going to be short on Thursday, maybe half an hour, 45 minutes if I get very, very distracted. But I know I get distracted, so I'm thinking 30 minutes with the distractions. If you want to go ahead and upload those, you'll be able to make another upload with the other screenshots there. But that'll count. Following along the class example will count for the points for our NoSQL coverage here. Just introducing it. DynamoDB is a good one. All of the cloud providers have something similar. It's roughly based off how we interact with MongoDB. So if you follow along with that, when you need to use MongoDB, it'll be it'll be kind of similar to that. Does anybody have any questions about that? I think I already asked that, didn't I? I'll still wait a couple seconds. Okay, I assume 5 seconds to silence means there's no questions. If you have any, let me know. We're wrapping up, so I assume everybody has stuff to do. That's why I decided to push the other one back to Thursday. That way you have this little block on your calendar where you can work on stuff because it's finals week in most classes, right? Remember, our final is on a calendar schedule, not a homework schedule. So the final exam is due Saturday, not Sunday. Everything is due Sunday this week because that's when the semester ends. Otherwise, I will see y'all on Thursday. Have a great day and enjoy the nice weather. If it's still nice out there, I don't have a window. It was nice before class. See y'all Thursday.